Let's read the question together. It's saying that a mismatch of 2% must achieve a CMRR of 60 dB and a differential gain of 5 at a bias current of 1 milliamp. So the current is 1 milliamp here, and RD is smaller than RO1. Find the minimum value of alpha. We know that RO equals 1 over lambda ID. The CMRR is 60 dB. Right, so 60 dB equals to 20 log CMRR. In that case, what is CMRR? This is 10 to the power 3. We are looking at differentially because differential gain of 5 and we have two outputs. So it seems like the question is asking me to find the CMRR, not single-ended, but differential. Basically, CMRR sometimes you need to find single-ended if it's asking single-ended. Right, just from looking at one output. But in this case, our CMRR is differential. That means our differential gain, which means when we apply a differential signal and we are looking at the differential output, the denominator will be, we apply a common mode, we apply differential, look at the output differential, we apply common mode, we look at the output differential, right? So if there's no mismatch, what would this be? 0. If we apply same inputs, output will be same if there was no mismatch, CM-wise. So, but there is mismatch, but it's not 0. Differential gain is 5. Differential applied, differential taken. And CM is, as you can see, it's very similar to this one. It's this, which is delta RD divided by 1 over GM plus 2 RE. What is REE in this case? So,
Hocam
if this is 5 over something thousand, this means this is 5 over 1000. If this is 5 over 1000, our delta RD divided by RD is 2%. RD is not given in this question. Oh, all right. Well, we definitely need to find GM. So how do you find GM? Do you remember the formula for the CMOS?
2ID over the overdrive.
Okay, we don't know the overdrive here, but we know K, right?
Root square of 2KID.
Okay, root square 2KI. This is I, so we divide it by 2. That's the I over 2, right? For the GM of this device. So that means K times I. K is mu times COX times omega over L. So it is square root 200 micro times 28. So this is 1, this is 200, so this will be 5,600. So this is 10, this is micro, this is milli, so this is 10 to the minus 9. So that's the GM. To find RO3, that's what we need, right? To find this, because we know this is 1 milliamp for this transistor. So it's asking us this one. That means we need to find this. To find this, we know this, we know this, we need to find this. And delta R over RD is 2%. And if that is 2%, so delta RD over RD is 2%. That means we need to find RD to find delta RD. How do you find RD? What is the gain of this differential amplifier? Differential gain.
5.
Formula-wise, minus GMRD, right? Saying absolute. So GMRD is 5. So we know GM, right? That means we can find RD. Right, so from here, let's say RD, we found 10K, 8K, or let's say 7K. Since RD is 7K, this is 0.14K. So 0.14K, we put it here. We found GM, 5 over 1000 already. So the only unknown is RO3. Okay, so we find RO3, we find alpha. Okay, any questions? Okay, well, as I mentioned here, it is important to know what CMRR you are finding. Normally, unless it is told to you, CMRR is a term for differential. That means output is differential. You apply a common mode signal, you look at differential output, means output this minus this. Input is you apply a differential, look at output. So this is CMRR. If I tell you, hey, what is CMRR single-ended? Single-ended, right? So what will be these terms? ADM, CM, and bottom will be ACM, CM. You are applying differential, you are looking single end, you are applying common mode, you are again looking single end. If there is no mismatch, this one is infinity, right? Because this is 0. But if there is no mismatch, this one is not 0, right? Even there is no mismatch, this is still something. You apply a signal, common mode signal, you get your output here. You apply two signals, same voltage, and you see some portion of common mode signal at the output. Why? This output signal divided by common mode signal, this one. And this is the formula, RC over 1 over GM plus 2 REE. So we want to make this as small as possible, right? But it is still something. So you apply some common mode, you still see a portion of common mode here. Why it's not 0? Why this is not 0?
Because RE is not infinite.
Exactly, because this is not infinite, right? Because we have this transistor looking here, we see RO3. Well, in this case, REE, right? So that's why this is not infinite. And let's multiply both sides with GM. GM, this goes, GM's come here. So top was GMRC. You apply differential, well, here RD in this case. And this one is you apply common mode. Look at common mode. So it's GMRD divided by 1 plus 2 times, what is this here? 1
RE, GM,
here will be RO
RO. Ha.
3, right? This is differential gain, output single-ended. This is common mode gain, output single-ended. So GMRD is cancel. This becomes 1 plus 2 RO3, okay? So if I tell you, hey, the single end CMRR is 80 dB. So this is 1000, 10,000. So then if 10,000 is 1 plus 2 RO3, that means RO3 is what? 5K, okay? So that's the important thing. If the CMRR is differential or if the CMRR is single end.